Hi, in this video, I will be showing you problem number 9 of chapter 14, section 2. Find the limit if it exists or show that the limit does not exist. Limit as xy approaching 0, 0, x to the power 4 minus 4y square divided by x square plus 2y square. So we have done the limits in one variable problems. Now, how is it defined in two variables, function of two variables, like this one? So x and y both approach 0, 0. A function of x, y is said to approach the limit L as x and y approaching AB. Limit as xy approaching AB of f of xy is equal to L. This means that the function f of xy approaches the limit, the number L, as the point xy approaches 0, 0 or AB along any path lying in that domain. Along any path that lies in the domain of the function f of xy. That's how the limit is defined. So earlier in single variable, we would say that the limit exists and the right hand side limit should be equal to same as the left hand side limit if it is in the case of a single variable. So we'll allow x to approach a from the right side, find the limit, then we will find x to approach a from the left, we'll call it left limit. Then the right limit must be equal to the left limit in order for the limit to exist. This is for the single variable case. Here in a multiple variable case like this one, as xy approaching AB along any path in the domain, the limit must be the same. If you have two paths that approaches the point AB, but the limits are different, then we say that the limit does not exist for that function. So in these problems, the limit does not exist case is usually easier than proving that the limit does exist. So let's see, we will find out we will see what happens in this case, whether the limit exists or not. So we can show that the limit does not exist by finding two different paths that approaching the point AB along which f of xy has two different limits. So we have to find out two paths approaching the point 0, 0 in our problem, because in our problem xy approaches the origin 0, 0. So we will find out two paths approaching the origin. So f of xy, which is equal to x to the power 4 minus 4y square divided by x square plus 2y square, then the two paths normally can be, the easy two paths can be one along the x-axis, one along the y-axis. So we will find out two limits. And then in this case, probably we will be showing that along the x-axis limit is different from along the y-axis limit. So approach 0, 0 along the x-axis. Any point on the x-axis will have an x-coordinate, some value, but y-coordinate is obviously 0. X-axis, on the x-axis, any point is x comma 0. So y-coordinate is 0. So limit as xy approaching 0, 0 along the x-axis will mean limit as x comma 0 approaching 0 comma 0, because y is 0 along the x-axis. So if you consider the function and substitute y equal to 0 there, x to the power 4 minus 4y square over x square plus 2y square is the function. In this one, we are going to plug in y equal to 0. So if we do that, it becomes x to the power 4 minus 0 over x square plus 2 times 0. Limit of that would be limit of x square, x comma 0 approaching 0 comma 0. As x anyway approaches 0, by direct plug-in, you get that to be equal to 0. So along the x-axis, we have now shown that the limit of f of xy is equal to 0. We'll choose another path. The easy path that we can choose, which is different from the x-axis, could be the y-axis. So now approach 0, 0 along the y-axis. On the y-axis, x is 0 and y is some value. So limit as xy approaching 0, 0 of f of xy is limit 0 comma y approaching 0, 0, because x is 0, x to the power 4 minus 4y square divided by x square plus 2y square becomes, if you plug in x equal to 0, you get limit of 0 minus 4y square divided by 0 plus 2y square. You can cross out the y square because y is anyway not 0, it's only approaching 0. So it becomes negative 4y square divided by 2y square, which is negative 2, as y is not equal to 0. Now, what we have shown is along the x-axis, the limit is equal to 0, limit of f of xy equal to 0, and along the y-axis, limit of f of xy equal to negative 2. So we considered two different paths, and then we approach to 0, 0. We approach to 0, 0 along these two paths, and then they yielded two different limits. As we get two different limits along two different paths approaching the point 0, 0, so the limit of this function does not exist at 0, 0. Does not exist at the point 0, 0. In the next example, in the next problem, we will try to show that the limit exists, which is a harder case than proving the limit does not exist. If you show that the limit does not exist, all you need to do is to find two paths, and along one path the limit is one value, along another path the limit is different. But when you have to show that the limit does exist, then you have to show that along every path in the domain, when the point approaches AB, the limit exists and it is equal to is the same along every path. That's more important. So we cannot choose just two different paths and prove it. If you are showing for two different paths it is the same, then you can come up with another path where the limit is not the same as the previous one. So we have to come up with a generic way of doing such problems. That is what you're going to see in my next video. We'll be discussing that for problem number 13. Hope this video for problem number 9 helps.